So in this video, we will solve paper 1, variant 2 for October-November 2021. So let's start with question number 1, part A, evaluate square root of 4900. So you will find out the prime factors for 4900. So this is divisible by 7. 7 is a prime number. 7 times 7 is 49 and then 2 zeros. Then again 7 times 1 is 7, 0, 0. Then 5 times 2 is 10 and then 0. 5 times 4 is 20. 2 times 2 is 4 and then 2 times 1 is 2. So if I write it down as a product of its prime factors, I have 7 square multiplied by 5 square multiplied by 2 square. So all of these are square. So what I can do is 7 into 5 into 2 whole square and then square root. These cancel out, square and square root cancel out. So your value will be 7 into 5 into 2, which is 5 twos are 10, 10 times 7 is 70. So your square root is 70. Evaluate 5 power 3. So this is 5 times 5 times 5. This is 25 times 5. 5 fives are 25, 2 carry, 5 twos are 10, 12, 125. Question number 2 is work out minus 8 plus 7 times minus 5. So first we'll do this multiplication. 7 times minus 5 is minus 35. This plus and minus become minus. Minus 8 minus 35 will give you minus 43. So your answer is minus 43. Question number 3 is shade one more small triangle so that the shape has rotational symmetry of order 3. So if you have rotational symmetry of order 3 and if you divide 360 degree with your rotational symmetry order, which is 3, you get 120 degrees. That means every 120 degree, if I rotate this shape, it should look the same every 120 degree in order to have this rotational symmetry order 3. So let me bring this diagram here. So this is the exact shape I have here. I'm going to rotate this 120 degree. So let's start the rotation. You can, once you have it in your question on your exam, you can rotate your question paper to, if you want to visualize this similarly. So now I have to see which is the missing shaded triangle after I have rotated it. Which one is missing that is shaded in the original one. So these are the shaded in the original one. I have this one which is missing, this one here. So that's the one I need to shade. So let's fill it up here and I can bring it back 120 degrees to its original orientation. So bringing it back to 120 degrees, this is the one I need to shade here. So it is this triangle that I should shade for it to have rotational symmetry of order 3. Once you have shaded, you can double check as well if it's the correct one. So this is the original orientation. I've shaded this one and then I can rotate 120 degrees. And the pattern of these shaded triangles is the same as in the original once I've shaded this one. So these three and these three are shaded, these three and these three are shaded. And then if I continue my rotation another 120 degrees, that brings me to 240 degree. Again, I get the same pattern that is in the original diagram. And then I come back to 360 degrees. So during the 360 degree rotation, you had the same exact shape 3 times, giving you rotational symmetry of order 3. So that's how you will solve this. Let's move on to next question number 4. Write down the name of the solid from each net. So you're given this net and you have to find which solid this net belongs to. So by looking at this, I can see this is a cuboid. I can draw this as well to help you visualize. So let's start with this. Let's take this as the base. of my net. So I'm drawing it a little tilted to give it a 3D feel so that it's easier for you to visualize. So I've drawn this. So to make it a cuboid, I will fold my net on this line here. So this will become a straight, it's vertically positioned like this, upwards. So once I fold it here, I have this, I've done this. I have this attached here on the top, right? It will come up as well once I fold this, and I have this attached to the side. So this will be my top lid of my cuboid. So I will bring it down like this. So let's do that. I will bring it down like this. To make the top lid, and this is done. So I have this on this side like this. I'll fold this to make the left hand wall of my cuboid. So if I make the left hand wall, I'll be left with this. So let me just erase this. So this is how I'm making cuboid. So this is done as well. So I have now this front side here, which is this one, and this side, which is attached on this. So this is still on the floor. I have not folded it. So let's fold it on along this line. This will move in this direction and become the front face of my cuboid here. So this will become a front face. And once I fold it up here, this will also come up and it will look like this. And then I can fold it like this to make the right hand side wall of my cuboid. So this will be my right hand side wall. So this is how this net, I'll use these as well. So this is how this net becomes a cuboid. So this is your cuboid. This one is a little simpler. The second one, this is a pyramid. So I have this base here, and then I have these rectangular sides that I can fold up along these folds. So if I fold this one upwards, this becomes my right hand side, this becomes my left hand side, and then you have the back side you fold up and the front side folds up to become the front. So this is your pyramid. And this third one, if I take this as the base and then I fold this upwards along, so I fold along this line, this becomes my back side. I fold along this line, bring this side up, this becomes my front side. Fold along this line, bring this side up from here to here, this becomes my back side, and fold along this line, bring this up. So it was like this before, but once I bring this up, this will become this face. So this is a triangular prism. I can flip it on this triangular base. So this will look like something like this. If this becomes this side, I'm flipping it so that this side is at the bottom. So I flip it on its triangular side, making it stand vertical like this to help you visualize better that this is a prism. So this will be a prism. Question number 4. Oh, sorry, question number 5. In the diagram, A, B, C, D, and E, F, G, H are parallel lines. These two lines intersect these two parallel lines, and you're given these angles. Find angle CXG. CXG is this angle here. So you can use the property of triangles that the external angle is the sum of two opposite internal angles. So for this external angle, the two internal opposite angles are these two. So CXG will be simply the sum of 53 plus 46, which is 99 degrees. There is another way to solve this as well, where you calculate this angle first. You know these two. Sum of interior angles of triangle is 180, so you can calculate this. And then this is a straight line. So this plus this should be 180. So once you have calculated this, you can calculate CXG as well. The next is find angle BCX. So BCX is this angle here. Since these two are parallel lines and this line intersects these two parallel lines, BCX is alternate to this angle. So BCX will be equal to GFX because they both of them are alternate angles. So this is 53 degrees. The next is find angle ABX. So ABX is this angle here. Again, this is an external angle of a triangle and it will be the sum of these two angles. This one we just calculated in the previous part. This was 53 degree. So ABX will be equal to 53 plus 81, which is 3 plus 1, 4, 8 plus 5, 13, 134 degrees. So ABX is 134. Question number 6 is work out 69 divided by 0.3. So 69 divided by 0.3. I can multiply by 10 in the numerator and the denominator so I can get rid of this decimal. So this will become 690 divided by 3. 3 twos are 6, 3 threes are 9, and 0, 230. Work out this, give your answer as a mixed number in its simplest form. So first I need to convert this into an improper fraction. 7 times 1 is 7, 7 plus 4 is 11 over 7. Then I'll change this to a multiplication sign and take the reciprocal. So this is 5 over 3. This is 55 over 21. So there are no common factors between 55 and 21. So I cannot further simplify. So I will convert this into a mixed number. So let's divide by 55 divided by 21. 21 times 2 is 42. 5 minus 2 is 3. 5 minus 4 is 1. So you have 2 whole 13 over 21. Question number 7. By writing each number correct to one significant figure, estimate the value of this. So this is your first significant figure. Next value is less than 5. So everything else becomes 0. Multiplied by, this is your first significant figure. Since this is a 0, this is not counted. If you're coming from the left hand, you look from left to right. And the first non-zero number is your first significant figure. So this is 4. Again, less than 5. So this will come 0.60. 1 is your first significant figure. Next number is 8. So this will be rounded up to 20. So 8,000 multiplied by 0.6. So I can just eliminate 1 0 and move the decimal one place to the right. So I have 800 multiplied by 6 divided by 20. So I basically taken 10 out of this and multiplied it by 0.6 to eliminate the decimal. Now it's easier for me to solve. Zeros cancel out. 2 times 1, 2 times 3 is 6. So I have left with 80 by multiplied by 3, which is 240. So your answer is 240. Question number 8, part A. Write 0.06 kilometers in meters. So you have to convert this into meters. You will multiply by 1000. 3 zeros. So you'll move it 3 times to the right, the decimal. 1, 2, 3. So this will become 60. Convert 7 meters square into centimeter square. 1 meter is 100 centimeters. Since it's a square, we'll multiply it by 100 square. So this is 4 zeros. 1, 2, 3, 4. 70,000 centimeter square. Write 216 as a product of its prime factors. So let's factorize 216. It's divisible by 2. 2 ones are 2. 0, 8, 16. Again divisible by 2. 2 fives are 10. 2 fours are 8. Again divisible by 2. 2 twos are 4. 1 14, 7. Now this is divisible by 3. 3 nines are 27. Again divisible by 3. 3 times 3 and then 3 times 1. So 216 is 2 power 3 multiplied by 3 power 3. So 2 power 3 multiplied by 3 power 3. Part B is two positive integers are each greater than 25. LCM is 216. The HCF is 18. Find the two integers. So let's call them A and B. So what do you know about these integers? They are greater than 25. So A and B are greater than 25. And their lowest common multiple is 216. So if LCM is 216, that means both of them are less than 216. And their highest common factor is 18. So now you have already written 216 as a product of its prime factors, which was 216 equals to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3. So this is 216 as a product of its prime factors. Now you know that the high LCM is 216 and HCF is 18. So that means if the highest common factor between A and B is 18, that means their prime factors should at least multiply up to 18, and we'll take 18 out of 216 because this is the LCM. So this is 2 twos are 4, 4 threes are 12, no, 3 twos are 6, and 6 threes are 18. So 2 multiplied by 3 multiplied by 3. So I've taken out this portion because this is the HCF, highest common factor, which is present in both A and B. So let me explain what I mean here. So let's take an example. Let's take 16 and 24 and let's calculate their LCM. First, we take the common factors, which is 2, 8s are 16, 2, 12, again 2, 4, and 3. So this is the HCF, and if we continue to find the LCM, we look at the individual numbers then. 2 twos are 4, 3 as it is, and then 2 ones are 2, 3 as it is, and then 3 ones are 3. So up till this point, we had the HCF, and the rest of the numbers were the remaining factors that were present in either 16 or 24. So I first eliminated, like brought it down to 1 for 16. So I divided by 2 again and then 2 again. And then I had 3 remaining here from 24. And then I took 3 out. So for HCF, you look at common factors, and then the rest of the factors are the remaining for one of the two numbers. So these two here are for when I'm factorizing 16 further down, 4 and 2, and then this 3 is for 3 is a factor of this 24. So similarly, if we apply the same knowledge, we know that 216 is the LCM and HCF is 18. So if you write 216 as a product of its prime factors, similar to what we did here, 18 is the HCF. So I've taken out 18, and both A and B have these prime factors of 18, which is 2 times 3 times 2 times 3 is 6, 6 times 3 is 18. Now what are the remaining factors, prime factors of 216? They are this 2, and this 3. Now they belong to either A or B, similar to what we had here. These 2 belong to these 16, and this 3 belong to this 24 when I was factorizing this 24. So similarly here, I have these 3 remaining prime factors which are left after I have taken out the HCF out of the LCM. So now I need to decide where do they belong. For sure, these two 2's will belong to the same number, either here or either here, because I cannot give this 1 2 here and give this 1 2 here, because then the HCF will change. HCF is what? All the common prime factors between the two numbers. So this 2 will also become common between the two numbers A and B. So the HCF will no longer be 18. HCF will now become 3 2s are 6, 6 3s are 18, 18 2s are 28, 36, and this 36. So now the highest common factor, we have changed it. It's no longer 18. So that means I cannot give this one 2 here and the other 2 here. Both of the 2's, these two prime factors belong to the same number. So we can give it to either of them. So let's give them to A. Now we are done with this. Now we have to decide, where does this 3 belong? Does it belong here or belong here? Remember, we are told that both numbers are greater than 25. So this is 3 2s are 6, 6 3s are 18. So that means this 3 has to be here so that B is greater than 25. A is already greater than 25. So that's how you will find these two numbers A and B. So let's now do the multiplication. 3 2s are 6, 6 3s are 18, and this is 4. So 18 times 4. 18 times 4. 8 4s are 32. 3 carry. 4 1s are 4, 72. And this is 2 times 3 is 6. 6 times 3 is 18. And 18 times 3. 8 3s are 24. 2 carry. 3 1s are 3, 5, 54. So the two numbers are 72 and 54. So you already had the prime factors for the LCM 216. You took out the HCF because you know the highest common factor is 18 and it should be present in both. So this was up till 18. This was the HCF. These are the uh, common factors. And then the remaining numbers, you had to decide whether these two 2's belonged here or this 3 belonged here. So remember, when you take the HCF, you take the lowest power of the prime factor. So what is the lowest power? 2 power 3 here, 2 power 1 here. So this is 2, and then this is 3 power 2, 3 power 3, 3 power 2. So this means 3 power 2. 3 power 2 is 9, 9 2s are 18. So HCF is 18. So you took out the HCF from your prime factors of your LCM, and then you decided you cannot give one 2 here and another 2 here because that would change the HCF. 2 power 2 will be here, 2 power 2 will be here, so this will actually become 2 power 2, but you cannot have that because you're told in the question that the HCF is 18. So both the 2's will belong to the same number, and the 3 will belong to the other number because you have to make it greater than 25. You're given that both numbers are greater than 25. So this question basically needed a bit of knowledge about LCM and HCF and how they are calculated and what the prime factors actually represent. So the common prime factors between the two represent the HCF, and then you continue to divide until you get one on both sides, one here and one here. This gives you the LCM. So we are basically first taking out the highest common factor and then continue to divide both numbers until you get down to 1, and then the rest of them multiplied with the HCF give you the LCM. So you applied the same knowledge here. You have the prime factors. You're given 18 is your HCF. You took out 18. You know for sure 18 is present in both A and B because it's a highest common factor. And then you basically distribute the rest of the prime factors into one of the two numbers based on the conditions that were given to you. So that's how you'll solve this problem. Question number 10, the diagram shows triangle A and triangle B. The first part is describe fully the single transformation that maps triangle A onto triangle B. So you're going from triangle A to triangle B. The size is not changing. The orientation is the same. There is no rotation as well. So this is a translation with vector. So let's find out the vector. We can take any two vertices. So translation vector is image minus object. So let's take this vertex 7 and minus 4. 7 minus 4, and then minus the object A, the corresponding vertex is 3 and minus 2. 3 and minus 2. So 7 minus 3 is 4. 3 and minus 2. And then minus 4. And then this will become plus 2. Minus 4 plus 2 is minus 2. Or you can also see, to move from here to here, you moved 4 blocks in the positive x and 2 blocks in the negative y direction. So your translation vector is 4 and minus 2. Part B is triangle A is mapped onto triangle C by a rotation of 90-degree anti-clockwise, center 0, 0, draw triangle C. So the center of rotation is this point 0, 0, and the rotation is 90-degree anti-clockwise. So I'll use my set square to do the 90-degree rotation. So how do you do the rotation? I'll connect each of these vertices with the center of rotation like this, and then like this, and the third one like this. So now you have to rotate 90-degree anti-clockwise. So that means, so let's take this vertex. This line is coming in like this to the center of rotation. It will be rotated in this direction. All of them that are connected to the center of rotation, they will rotate 90-degree anti-clockwise, which is this direction. So the distance of these vertices will remain the same from the center of rotation. So let's let me actually mark these P, Q, R. So let's first find the image of P and let's call it P prime. So the distance of P is almost 3.2 centimeters from the center of rotation. So now I'll use my set square uh, and rotate 90-degree. So I'll align my set square with this line here. So let me place it here and then align it like this. Okay, now it's aligned. 90-degree angle will be this. So I'm coming from this and I have to go almost 3.2 centimeters. So this is P, which is the object. This is the line connecting to the center of rotation, and then you go 90-degree anti-clockwise like this, the same distance 3.2, which lands you here on this point. So this is your P prime, and then you repeat the process for the other three vertices as well. So let's find the length of, or the distance of Q. It's almost 4.5 centimeter, and then I'll use my set square. First align it with my line that is connecting. So this is almost aligned. So now I have to go 4.5 centimeters. Again, this will be also be in anti-clockwise. So you're going 90-degree like this. So 4.5 is here. So if I connect this line to this point, or this, let's connect P prime like this. This angle is 90-degree because we marked this point using a set square, and you know that the set square has the 90-degree angle. All right, now we have one last. So this was 2, 3 was our, this was our P prime. This is our Q prime. Now for R, again, I'll measure the distance. R is almost 4 centimeter. And then let's align it here. Place it at our center of rotation with 0 at center of rotation, and then 4 is almost at this point. So this is our R prime, the image of this point R. And if I connect these three lines, I will get my triangle C. So this is my triangle C. I can erase these because they are not required. You only need to mark triangle C. So this is how you will image A onto C using rotation 90-degree anti-clockwise with center 0, 0. The next part is triangle A is mapped onto triangle D by an enlargement of scale factor 3 and center 5 and minus 5. So if we go back up, center of enlargement is 5 and minus 5, and you're enlarging triangle A. Scale factor is 3. So to enlarge, you will again, let me join the points with the center of enlargement. So all the three vertices join like this. So let's start with this vertex. So your scale factor is 3. So that means it's positive. So your triangle D will be on the same side of the center of enlargement as triangle A. If it was negative, the enlargement, the image will be on the other side of your center of enlargement. So this is positive, positive 3. So the image will be on the same side as the object. Scale factor is 3. That means you will triple the distance of each vertex from the center of enlargement. So let's see if this is, let me measure this. This is almost 3.2 centimeter. So this is P, let's call this P. P prime will be 3 times the distance as P from your center of enlargement. So this is 3.2. You'll go another 3.2 in the same direction, and then you'll go another 3.2. So let me draw the line as well. So you'll keep going in this direction. So another 3.2 will bring you here, and then another 3.2 will bring you here. So now distance of P prime is 3 times the distance of this P. Similarly, for this, you have to triple the distance. So this is 3 blocks in the x direction and 1 block in the y. So you go another 3 blocks in negative x and 1 block in y. So this is double, and then you keep going till this point to triple your distance. And then similarly here, 1 block, 2 blocks in negative x, 1 block in positive y. 2 block in negative, 1 block positive x, and then another 2 blocks negative y, 1 block positive x. So this is triple the distance. This distance, if this is the distance of, let's call this q, this is double, and then this is triple, you get q prime, and let's call this r, and this is r prime. I can join this with a straight line as well. And if you measure the distance of q and compare it with q prime, you will see that the distance of q prime is 3 times the distance of q from center of enlargement, which is 5 and minus 5. So now you have all the three vertices, 4 and minus 1, sorry, minus 1 and 4, minus 1 and minus 2, and minus 4 and minus 2. So this will be your triangle D. This is your triangle D. And you can also see that all the three sides have increased by a factor of 3. This was length 1, this is length 3, this was length 2, this is length 1, 2, 3, 4, 5, 6, and you can measure this as well. This is also 3 times the length of this. So that's how you will do this enlargement. All right, let's move on to the next question. Question 11. The scale or drawing shows a garden with two trees P and Q. The scale is 1 centimeter representing 6 meters. The garden has a path that is equidistant from P and Q. Using a straight edge and compass only construct this path. So now you have to basically uh, draw the perpendicular line bisector of this line PQ. Will be something like this. So all the points on that line will be equidistant from both these points P and Q. So to draw the line bisector of line PQ, I will open up my compass more than half the length of PQ. Placing it at P first, I'll draw the two arcs on either side. One here, another one here. Then without changing the length of compass, I'll place it at Q and then draw another two arcs like this and like this. So if I join these two arcs with a straight line, I will get my perpendicular line bisector. So the garden has a path, so it's inside the garden, so we'll draw the line inside the garden only. So it will be something like this. This is your perpendicular line bisector of this line PQ, and all the points on this line will be same distance from point P and point Q. Part B is Yuna wants to plant a third tree in the garden that is nearer to Q than to P and more than 18 meter from Q. So go back here. So this third tree is nearer to Q than to P. That means it will be on the right hand side, on this side of this line bisector. So it is nearer to Q, but it has to be more than 18 meter from Q. Shade the regions where Yuna can plant the tree. So we need to first find uh, the points that are 18 meter from Q, and you're given the scale is 1 centimeter is 6 meters. So centimeters to meters, given 1 centimeter is 6 meters. Now we need to find how many centimeters is 18 meters. So let's call it X. They are directly proportional. More centimeters in this drawing means more meters in the real world. So 6x equals to 18. I'll basically cross multiply it, and x equals to 3. So now you have to draw a circle of radius 3 centimeter around Q, which will give you the points that are 3 centimeter on this drawing, but in real world 18 meter from Q. So let me get this out of the way. I'll use my compass to draw this circle. I'll open it up to 3 centimeter. So place it at 0 and then open it up till 3 centimeters. Center it at Q and then draw a circle like this. Again, you don't need to go outside the circle, but now I've drawn it, but you can only like remain inside the circle, inside the garden, because the third tree is being planted inside the garden, not outside. So now what are the two conditions? The third tree is more than 18 meters. So that means it has to be outside this circle to be more than 18 meters from point Q. But it also has to be nearer to Q than P. So that means it has to be on the right side of this line. So that gives you these two regions in which the third tree can be planted, which satisfy both the conditions that the third tree is more than 18 meters from Q and closer to Q than P. So these two regions satisfy both conditions. They are outside the circle that we have drawn, which represents 18 meters around point Q, and they are on the right hand side or this side of the line bisector of points P and Q. So these two regions are the regions that you have to shade where the third tree can be planted. Question number 12. The diagram shows a rectangle ABCD. E is a point on the diagonal and this angle is given as 90 degree. Prove that triangle ADC is this, is similar to triangle DEC. DEC is this in smaller triangle. So we can see that this angle is shared between the two triangles, so it is same. In this red triangle, this angle is 90 degree, which is given. And since this is a rectangle, that means this angle ADC is also 90 degree. So two angles are same. That makes the third angle, which is this one in this triangle and this one in this triangle, same as well. So let's write it down. So let's first start with this, which is the common angle. So ACD equals to ACD is same as DCE. DCE because it is a shared angle. And then you have angle ADC equals to angle DEC. DEC equals to 90 degree. This is given. This is given. And then the third angle automatically becomes equal. So angle DAC of this blue triangle is equals to angle EDC of this red triangle. EDC are same because these are the third angle in the two triangles. So all three angles are same. So triangles are similar. Question number 13 is the mean of 5 numbers is 17. Then you're given a bunch of conditions. Let's list the 5 numbers in order of size. So you're given that the numbers are listed in order of size starting with the smallest. The 3 smallest are equal, the middle 3 add to 35, the largest number is 4 times the smallest number. So let me write down the 5 numbers. First number, second number, third number, fourth, and then fifth. So you're given that the 3 smallest numbers, so let's assume that this is from smallest to largest. I've written down smallest to largest in this direction, the 5 numbers that are in question here. So the 3 smallest numbers are equal. So let's call them X. The 3 smallest are X. The middle 3 numbers add to 35. So middle 3 are these 3 middle ones. So let's call the fourth number Y, and then you know that these 3 add up to 35. So let's find Y in terms of X so that we have just one variable. So y will be equals to 35 minus 2x. So I can replace this with 35 minus 2x. And the largest number is 4 times the smallest number. What is the smallest number? X. So your largest number is 4x because it is 4 times the smallest number. Now you're given that the mean of these 5 numbers is 17. So let's calculate their mean. How do you calculate the mean? You add the 5 numbers, x plus x plus x plus 35 minus 2x plus 4x divided by 5 because you're calculating a mean of 5 numbers equals to 17. So 3x minus 2x, x plus 4x, 5x. 5x plus 35 will equal to 17 times 5. I'll take this 5 to the other side. 17 times 5 is 35, 385. 5x will be 85 minus 35, which is 50, and x will be 10. So your first number is x, which is 10. Second number is also x. Third number is also x, 10. Fourth number is 35 minus 2x, 2 times 10. 35 minus 20, which gives you 15. So this is 15, the fourth number. And the fifth number is 4 times x. 4 times 10 is 40. So this is the list of numbers in order of size starting from smallest to largest. So 10, 10, 10, 15, and 40. And you can also double check these conditions still satisfy. Three smallest numbers are equal. They're equal. The middle three add to 35. 10 plus 10, 20 plus 15, 35. The largest number is 4 times the smallest number. Largest is 40, which is indeed 4 times the smallest number, which is 10. 4 times 10 is 40. Question number 14. The diagram shows the speed time graph for the cyclist journey. So speed on y-axis and time on x-axis. Find the acceleration during the first 20 seconds. So acceleration is rise in the first 20 seconds and run. Rise is 15, run is 20. 15 over 20 meters per second square. Describe the motion of the cyclist between t equals to 20 and 30. So what is the motion between t equals to 20 and 30, which is this duration? The speed is constant. Speed is constant. Find the total distance traveled in 50 seconds. So distance traveled is area under the speed time graph. So you have to find this area underneath this graph. So I can divide this into two parts. This is my first part and this is my second part. Both of them are trapeziums. So I can calculate the area of this trapezium and this trapezium separately and then add them together to find the total area under the graph, which will give me the distance. So let's look at the first trapezium. So I'll just write it down as total distance equal to, let's find the area of this first trapezium, which is 1 by 2 into height. What is the height? This is the 90-degree angle. The height is 15 multiplied by the sum of parallel side. This is 30, the first parallel side. And what is this distance? The other parallel side is 30 minus 20, which is 10. So 30 plus 10 will be the sum of parallel sides. Plus the area of this second trapezium. Again, 1 by 2 into, now this is your height, like this. And these are the two parallel sides of the trapezium. So now the height is 50 minus 30. So this is 20. So 1 by 2 into 20 into sum of parallel side. This side is 5. 5 plus this side is 15. 15. So now let's solve this to find the total area. 30 plus 10 is 40. So 1 by 2 into 15 into 40 plus 1 by 2 into 20 into 20. 2 ones are 2. This is 20. 15 times 20 will be 300 plus This is 2 times 1, 2 times 10. 20 times 10 is 200. So 300 plus 200 is 500 meters is your total distance traveled by this cyclist. Question number 15. During 1 year, the value of a bicycle decreased from $200 to $160. Calculate the percentage decrease. So for percentage decrease, you need the decrease in value, decrease in value divided by original price, original price, and then multiplied by 100. So what is the decrease in value? It decreased from 200 to 160. So the decrease is $40. Original price is 200 and then multiplied by 100. So zeros cancel out. 40 divided by 2 is 20%. So the percentage decrease is 20%. Solve the inequality. So I'll break this minus 6n to this side. On the left side, it will become plus 6n. Take this 23 to the other side. So greater than 5 minus 23. 8n is greater than 5 minus 23 will be minus 18. And n will be greater than minus 18 over 8. I can divide by 2 to get the simplest form. So this will be 9. 2 times 9 is 8. Sorry, 2 times 4 is 18. 4 is 8. And 2 times 9 is 18. So this is minus 9 over 4. N is greater than minus 9 over 4. Factorize this expression. So from the first two terms, I can take y common. So here I'm left with 3x minus q. And from the next two terms, I can take 2 is common and p is common. So plus 2p common. Then I'm left with 3x here and minus q here. So 3x minus q is common. So this will be 3x minus q into y plus 2p. So 3x minus q into y plus 2p. Question number 18. The diagram shows a shaded region ABC. The equation of line AC is given. Write down the three inequalities that define the shaded region. So line AC, you're given y equals to minus 1 by 2x plus 5. This line here, line AB, the equation is x equals to minus 4. And this line BC is y equals to 2. So now the three inequalities will be, so this is towards the right side of x equals to minus 4. So this is x is greater than equal to minus 4. You have to include equal to here as well because this is a solid line. And then this is above this line, y equals to 2. So this is y is greater than equal to 2. And for this third line, it's below this line. So this will be y is less than equal to minus 1 over 2x plus 5. So these are the three inequalities that define the shaded region. Question number 19. ABC lie on a circle. The line, this PBQ is a tangent to circle B. OCQ is a straight line. This angle is 36. This is x degree. Find the value of x. So you know that this is a tangent. This is center. So this line is OB. You know that radius and tangent make 90-degree angle. So I know these two angles of this triangle. I can find this one. And once I find this one, I can find x because This angle at the center and this angle x are subtended by the same segment here. One is at the center and one is at the circumference. And you know that angle at circumference is half the angle at center, given that they're formed by the same segment of a circle, which is true in this case. So let's first find this angle OBQ. So your angle OBQ plus, oh, not sorry, not OBQ. We know OBQ is 90. Your angle QOB. QOB plus 90 degrees, this one, plus 36, this one, equals to 180. So angle QOB will be 90 plus 36 is 126. So this is 180 minus 126, which is 54 degree. Now you know that if this is 54 degree, angle at center is twice the angle at circumference. So the x value will be uh, QOB divided by 2, which is 54 divided by 2, which is 27 degrees. 2 times 2, 114, 7, yeah. So x is 27 degrees. Question number 20. You're given this matrix, you have to find the inverse. So power minus 1 means inverse. So to find the inverse, first you need to find the determinant of this matrix, which is 3 times 2. You multiply these two terms, 3 into 2, and then minus the product of other two terms, which is 1 times minus 2. 3 2s are 6. This will be minus 2, and then this minus and minus become positive, so plus 2 equals to 8. So the inverse will be 1 over determinant into the multiplied by the adjugate of the matrix. So 1 over determinant is 8, and to find the adjugate, you swap the places of these two terms. So this 2 comes here, 3 comes here, and you change the sign of the other two terms. Minus 2 becomes plus 2, and 1 becomes negative 1. So you can write it as it is, or if you want, you can take this 1 over 8 inside. So this will become 1 over 4, 1 over 4, minus 1 over 8, and 3 over 8. So your inverse is this 1 over 4, 1 over 4, minus 1 over 8, and 3 over 8. Question number 21 is the cumulative frequency diagram shows the masses m grams of 120 eggs. So on the y-axis you have cumulative frequency, x-axis you have the mass in grams. So part A is use the diagram to estimate the median. So your median value will be the mass at the 50th percentile of your cumulative frequency. So total frequency, which is 120. So 50% of 120 is 50 over 100 into 120. So this is 60. So you have to find the mass value when your cumulative frequency is 60. So let's do that. I'll draw a straight line, this up till the curve, and then read the value of mass here. So if you come back down here, so this value here is 58. One small block is 1 gram, so 50, 55, 6, 7, 8. So 58 gram is your median value. So 58. Part B is the interquartile range. So interquartile range is the upper quartile minus the lower quartile. So let's find those first. So upper quartile, let's find the value of the upper quartile, which is at 75% of your uh, total frequency, which is 120. So 75% of 120 will be 75, 100, 120. Zeros cancel out. 75 times 12. 5 twos are 10, 1 carry, 14, 15, 5 and 7. So 0, 10, 1 carry, 9. So 900 divided by 10, which is 90. So your upper quartile, you have to find the mass when your cumulative frequency is 90, which is at this point. So let's draw a straight line up till the curve, which is this, and then we go down to find the value of mass. So this here is 62. So your upper quartile is 62, and then lower quartile is your mass at 25% frequency of total frequency. So 25% of 120 will be 25 divided by 100 into 120. Zeros cancel out. 25 times 12 would be 25 times 10 is 250 plus 50 300 divided by 10. So this is 30. So now you have to find the mass when your cumulative frequency is 30. So 30 would be this point. Let's draw a straight line again and then read the value of mass. So this here is 51. So your lower quartile is 51, and then your interquartile range would be interquartile range would be 62 minus 51, which is 11 grams. So 11 grams is your interquartile range. Part B is eggs are described as large if their mass is 63 grams or more. How many of these eggs are large? So now you're looking for eggs that have a mass of 63 grams or more. So if I go back up here, 63 grams is this value here. So let me draw it in red. So this is 63 grams here. And then if I draw a straight line up till the value of curve here, so it intersects at this point, and this is 99. So cumulative frequency here is 99, and you're looking for eggs that have a mass greater than 63, which is in mass in this value, and the eggs are in this window here. So this is 120 minus 99. So number of large eggs would be 120 minus 99, which is 21. So you have 21 eggs which have a mass which is greater than 63 grams, uh, which are in this window here. So you found out 99 eggs have mass less than equal to 63, and the rest will have greater than 63 grams. Question 22, part A, solve this. 27 power k equals to 9. So to compare the powers, we need the coefficient at the bottom here to be the same. So both are multiples of 3. I can write 27 as 3 power 3. 3 3s are 9, 9 3s are 27. And this power k. And I can write 9 as 3 square. And then if I bring this power in, it will be multiplied. So this will be 3 power 3k equals to 3 square. Now my base here is same. So I can directly compare the power values, which is 3k equals to 2, k equals to 2 over 3. Part B is simplify this expression. So I'll bring the power again inside and it will be multiplied. So 16 power will become minus 1 over 4 and x power 8 multiplied by minus 1 over 4. So this will be 16 power minus 1 over 4 divided by 4 ones are 4, 4 twos are 8. So this is x power minus 2. So to make the power positive, I'll take this into the numerator and bring this into the denominator. So both powers will become positive. So this will become 16 squared divided by, sorry, x squared divided by 16 power, now positive 1 over 4. Now I can write 16 as 2 power 4 because 2 into 2 into 2 into 2, 4, 8, 16. And then this was power 1 over 4. Then if I bring this inside, multiply by this 4 and this 4 will cancel out. So I'll be left with x square over 2, which is your final answer, x square over 2. Question number 23 is y is inversely proportional to x plus 1 whole square. So that means y is directly proportional to 1 over x plus 1 whole square. Or I can write this as y equals to k over some constant k over x plus 1 whole square. When x equals to 1, y equals to 5. Find y when x equals to 9. So first we need to find the value of k using these two values given. So let's substitute these. Y is 5, k over x is 1. 1 plus 1 whole square. So this will be 2. 2 square is 4 and k will be 20 once I take this 4 and multiply by 5 on the other side. So now you have y equals to 20 over x plus 1 whole square. Now find y when x equals to 9. So y equals to 20 over x is 9. 9 plus 1 square. 9 plus 1 is 10. 10 square is 100. So 0 zeros cancel out. 2 ones are 2. 2 fives are 10. So y equals to 1 over 5. Question number 24. You're given f of x and g of x. Find f of 3. So f of 3 will be, I'll substitute x with 3. So 2 into 3 square plus 7 into 3 plus 4. 3 square is 9. 9 twos are 18 plus 21 plus 4. 21, 31, 39. 39 plus 4 is 43. So this is 43. G inverse of x. So we let y equals to g of x, which is 2x plus 6. Then to find the inverse, I'll make x the subject of this equation. So I'll take this 6 to the other side. Y minus 6 equals to 2x. So y minus 6 over 2 equals to x. So now you have x equals to y minus 6 over 2. And once you have that, your so this is actually g inverse of y, which is y minus 6 over 2, because your y was equals to g of x that you wrote down here. So x, if I take this g inverse to the other side, g inverse of y equals to x. So that's what I'm using here. G inverse of x is g inverse of y. So I substitute x with g inverse of y. And now I have g inverse of y equals to this. So to find g inverse of x, I'll simply substitute y with x here. So g inverse of x would be x minus 6 over 2. So g inverse of x is x minus 6 over 2. Part B is solve f of x minus g of x equals to 1. So f of x is this. 2x square plus 7x plus 4 minus g of x is 2x plus 6 equals to 1. So let's open the bracket first. So this comes down as it is. So this will become minus 2x plus minus will become minus 6 equals to 1. So 7x minus 2x will be 5x. 4 minus 6 is minus 2. Minus 2, and this will become minus 1 equals to 0. 2x square plus 5x minus 3 equals to 0. Now I can use the I can factorize this expression to solve for x. So to do that, you will multiply this constant with the coefficient of x square. So minus 3 times 2 equals to minus 6. So since this is a negative sign, I'm looking for factors of 6 that if I subtract them, I should get 5. So 6 and 1 are the two factors. 6 times 1 is 6, and 6 minus 1 is 5. So this will be plus 6x minus 3 equals to 0. From these two, I can take 2x common. I will be left with x plus 3. Nothing common here, so minus 1. So the signs will change inside. So this will become plus x, and plus 3 equals to 0. So this will be 2x minus 1 multiplied by x plus 3 equals to 0. So if the product is 0, that means one of the two terms is 0. So either 2x minus 1 equals to 0 or x plus 3 equals to 0. So this gives you x equals to 1 over 2, and this gives x equals to minus 3. So the two possible values of x are 1 over 2 and minus 3. Question number 25 is 40 students can take part in 3 activities: art, dancing, and gardening. You're given some conditions. First part is complete the Venn diagram. So the first uh, point given is 5 students do not take part in any of the activities. That means they are outside of all three circles, which represents art, dancing, and gardening in this Venn diagram. So 5 will be outside here because these students do not take part in any of the activities. 12 do art only. So which area here represents art only? It is this one, which is inside A but outside any other intersection. Because they're doing art only, they cannot be in any of these intersected areas because these students take part in multiple activities. Like X is art and dancing, this part in the middle is all three activities, and this part here, which is 0, is art and gardening. So art only means 12 students are here in this part of this circle. 4 do dancing and gardening but not art. So dancing and gardening is this intersection, but this part also includes art, the circle A. So 4 will be here because they do dancing and gardening but not art. So they will be outside of this circle A but within the intersection of this D and G. One student does all three activities. So the intersection of all three circles is this part here. So one student does all three activities. So this will be here. So that's how you will complete this Venn diagram. Part B is on the Venn diagram, the ratio x ratio y ratio z is 1 ratio 2 ratio 3. Find the value of x, y, and z. So if x ratio y ratio z is equal to 1 ratio 2 ratio 3, that means y is 2 times of x, right? That's why x ratio y is 1 ratio 2, and x ratio z is 1 ratio 3. That means z is 3 times of x. So y is 2x and z is actually 3x because it is 3 times x. The ratio is 1 ratio 3. So now I can add up all these students, and they should add up to 40 students because uh, the total number of students given here is 40. So let's add them all using this Venn diagram. You will add students in every region. So you have x here, which is x plus 12 plus 12 plus this 1. This is 0, so I can ignore. Plus this 5 plus this y, which is 2x, plus this 4 plus this z, which is 3x. And they should all add up to 40. So let's solve for x, and then we can find y and z as well. So x plus 2x, 3x plus 3x is 6x plus 13 plus 5, 18, 18 plus 4 is 22. So 22 equals to 40. 6x will be 40 minus 22, which is 18, and x equals to 3. So if x is 3, Y is 2x, which is 4. Z is 3x, which is 3 threes are 9. So x is 3, sorry, y is 2x, which is 2 times 3, which is 6. Y is 6, Z is 9. Part C is one subset in the diagram. Part A has no students. Use set notation to describe this set. So there are 0 students in this area here. And you have to describe this using your set notation. So how would you describe this area? This area involves A and G, their intersection. So it will be at least A intersection G first. But A intersection G also includes this area, which is in red. So red plus blue is A intersection G. Now we have to exclude this because we are only looking for this area, which is blue, which has 0 students. So this blue area is outside of D. Everything outside D is D complement, and then you find its intersection with this area, with A, sorry, A intersection G will give, so A intersection G and then intersection with D complement because it's outside of this circle D. So A intersection G gives you this whole thing, and then you have to exclude everything inside D, so you do intersection with D complement, giving you this blue shaded area. So that's how you will write the set notation to describe this area which has no students or 0 students. Part D is find number of students in D union G intersection A. So let's first look at D union G. Let me erase this. So D union G is everything inside of D and everything inside of G. So this blue area is D union G. And then you're looking for intersection of this area with A. Which part is A? So A is this. This green part is all A. So intersection is which are the common areas between this blue, which is D union G, and this green, which is A. The common area is, let me mark it in yellow. This is the common area. That is part of both the green region and the blue region. So how many? So you have to find how many number of students are in this area. You have x plus 1 plus 0. So I can just ignore the 0. So number of students in D union G intersection A is x plus 1 plus 0, which I can ignore. Your value of x was 3, 3 plus 1, which is 4. So there are 4 students part of this set notation that is given D union G intersection A, which is represented by this yellow area here. So that was the last question of this paper.